So the degree of a monomial is the sum of the variable exponents of a term. The degree of a polynomial is the sum of each of the monomials. It's the highest one. So the highest monomial degree. A monomial, we know, is a single term expression. So it only has one term. Like, for example, 3x cubed. 3x cubed y is a single term. A polynomial is a three or more terms.
I thought it was 4.
It's 4 or more.
Yeah, it's actually 4 or more. Yeah, it's more than 3 terms, but it's really 4 or more terms. Trinomial is 3 terms. Binomial is 2 terms. Quadratic is a polynomial that has a degree of 2. Cubic is a polynomial with a degree of 3. Okay.
So the vocabulary.
The degree of a polynomial, we already talked about. Cubic, we already talked about. Degree of a monomial. Leading coefficient. The leading coefficient is the number in front of a term. So the leading coefficient is the coefficient of the first term in a polynomial when it's in standard form. It has to be in standard form first. A perfect square trinomial is basically the product of something, a binomial that has been squared. A quadratic is power of 2. The difference of perfect squares is the polynomial that gives you the answer a squared minus b squared, but it comes from what we just did as the example, a plus b times a minus b, where the middle term cancels out. And the standard form of a polynomial is when it is in descending order, so the highest degree goes first, of exponents. The rest of your Chapter 6 test, which will have the second part of Chapter 6, Part 2, is going to be on Thursday. You will be expected to simplify expressions when the exponents have to be simplified further. So, for example, if I gave you something like 35 x to the 0, y to the 3, you would have to know that this simplifies. The x to the 0 becomes 1. So it just sort of goes away. So this would just simplify to 35y to the 3rd. You also have to make sure that you remember, when simplifying, negative exponents. So if I had something like 12 to the power of negative 4, you have to know that a negative exponent says, hey, I'm a fraction, and I actually belong in the other location. And you would just simplify it to 1 over 12 to the 4. Now, if they asked you to evaluate it, you would be able to use a calculator and actually multiply it out. Another type of example of simplifying that you're going to have is the simple ones, such as this, where you recall when you're multiplying, you're going to multiply the coefficient. So 5 times 2 is 10. X to the power of, you add their exponents, 7, and y to the negative 2 plus 3 is 1. If one of the exponents turned out to be negative, you would have to make sure that you relocate it. Same thing with quotients, division. 4x to the 4, y to the negative 2, z to the negative 2. over x to the negative 5, y to the 0, z to the 0. I would first simplify negative exponents because it makes it easier to work with. So the first thing I would do is I would bring negative exponents to where they belong. So this one would come up top. This one would go to the bottom, as would this. The other ones remain. So 4x4 stays. The x to the 5 comes on top as a positive. The y to the negative 2 now becomes positive on the bottom. Y to the 0 and z to the 0 go there. And the z to the negative 2 comes down to the bottom. Now at this point, both exponents of 0 become 1. Both expressions with exponents of 0 become 1. So this becomes 1 and this becomes 1, which really just cancels out because 1 times 1 is just 1, and it's not going to change the value. From there, you get 4x to the, well, you have 4 x's here and 5 here. That means you have a total of 9. And the denominators are different variables, so you can't combine them. Numbers 5 and 6 ask you to classify the polynomial.
I got 5 of them because of...
So if I asked you to classify 12x5y2, you would say that this is a 7th degree monomial. Remember, you add the exponents of the terms. Similarly, if I asked you to give me something like this, and I asked you to classify this one, you first have to figure out what each term's degree is. The first one is 2 plus 2 is 4 plus 1 is 5. This is 3, and this is 1. So this would be called a fifth. And how do I call the fifth degree? Quintic. Quintic trinomial.
Are we gonna have the?
Yes. Then we have standard form. Make sure you know that when you are identifying things in standard form, they must be in descending order of exponents. So for example, if I gave you something like this here, that's not in standard form. In order to put it in standard form, you put the one with the largest exponent first. Then you go in descending order of exponents. Okay, that's standard form. When you're adding and subtracting polynomials, you have to make sure that you put them in standard form. So that goes to the next part, which is to add and subtract polynomials. So if I was to give you, and this I believe, I'm not going to spend too much time on this because I think you guys are pretty strong on this, but if I was to give you an example such as this, hopefully you would notice that the difference between this question and the questions where you're multiplying, foiling, is that here there's a minus in between them. So that means you've got to distribute that negative first, and if it's a positive, the distributing doesn't do anything. So you're going to get 5x squared plus 7x plus 12x squared minus 6x plus 5, and then you combine like terms. 17x squared, 7x minus 6x is 1x, and then plus 5. That's in standard form, so that would be your answer. So remember that when you're subtracting, that subtraction has to be distributed to everything in front. Then you just combine like terms. No, we're not done yet. I'm reviewing for what's going to be on the total, like the big test for chapter 6. So then you are also going to have to multiply. So when you're adding and subtracting, that's pretty straightforward. Then you guys learned about multiplying. And it kind of was an extension from last year where we learned when multiplying variables add their exponents power to power, you multiply. But we also had expressions where you're multiplying binomials and polynomials. So a simple expression such as this, if I asked you to multiply, you would just do 5 times negative 2, x to the third, y to the sixth, because you have 1 here, 5 there, 6 total. The other types of multiplication are going to be the FOIL method, x plus 4 times x plus 5. And again, you can use the box method if it helps you. I would prefer that you think about the FOIL method and make sure you understand that, the distributive method, so that when we're going to go factor or unfoil in the next unit, it's going to make sense to you. So you would basically just multiply the first term times the first term. Then you can do that, same x to the next one. Then you move over to the 4 times the x, and then the 4 times the 5. Combine those like terms, and you get x squared plus 9x plus 20. You get a quadratic trinomial when you multiply two binomials. If we are multiplying multiple terms, not just binomials, you remember that what you do is you multiply each of the first terms to the guys on the other trinomial. So I would take this one, and I would take the first one, and it's the same method as with FOIL or as with the distributive. You take the first term of the first parentheses, multiply it, and you get 3x to the third. Then you make sure you distribute that same number to the 3x, so that's 9x squared. Then you go to the 3x times negative 2, and you get negative 6x. And you're not done, because now you have to move over to the negative 5. Negative 5 times x squared is negative 5x squared. Negative 5 times 3x is negative 15x. Negative 5 times negative 2 is positive 10. And then you combine like terms and write it in standard form. 3x to the third remains. 9x squared minus 5x squared is positive 4x squared. Negative 6x minus 15x is negative 21x. And then that plus 10 just gets rewritten. And that's your final answer. Similarly, if you have special case scenarios, you're welcome to either follow the rules that you could have memorized or always, when in doubt, write it out. So if I was to ask you to multiply 2x minus 3 squared, hopefully you understand that this is the same thing as 2x minus 3 times 2x minus 3. So you could take it the long way and write out 2x minus 3 times 2x minus 3, and then you can distribute or FOIL. 4x squared minus 6x, another minus 6x, plus 9. Combine like terms in the middle, and you get 4x squared minus 12x plus 9. The shortcut way is to think, oh, if I'm squaring it, I can use the special a plus b squared is really a squared plus 2ab plus b squared, if you're good at memorizing things, and you would have gotten the same answer. If you prefer to write it out, there's nothing wrong with that, and I would prefer that you write it out to make sure that you get it correctly. You notice that when you're squaring a binomial, you're going to get a trinomial in which the first term of the trinomial, so if we're looking at 4x squared, the first term of the trinomial is really the square of the first term of the binomial. 2x squared is 4x squared. The last term is the last term, negative 3 squared. And the middle term is when you multiply the two numbers, negative 6x, you double them. That's where you get the negative 12x. That's where the shortcut comes in. On a similar line, you also learn that the difference of perfect squares is when you're multiplying two binomials that are what we call conjugates. X minus 5 times x plus 5 is a special product. It's going to cancel out the middle term. So if you forgot that, but you still wrote it out the long way, you would notice that the middle term cancels out and you just get x squared minus 25. Those are all the types of questions that are going to be on your test on Thursday, okay? Every single question that you see here is the type of question that you're going to have. There's no additional questions that are going to be tricking you. Everything that you see is what you get. Make sure that you feel comfortable with all of these.